Welcome to the second video tutorial of MCTDHX. I'm so happy to be here with you. I'm gonna tell you a little about the structure of the program and the commands that you will be using. So hopefully you have followed the zero tutorial and you have installed successfully MCTDHX. Is now on your machine, it runs and everything is fine. So if you go to the installation folder, to the directory, in my case it's under documents, find this series of files and folders from which now you need the bin folder. So just let's check that everything works fine and go to the bin, and you have to have three files there, two of which are the executables, and the third one, the library, is the library, which collects all the information about the parameters and potentials and stuff when you compile. So that's why I told you earlier that you do not need to compile every time you want to run to execute the program, but rather you just give some values to the parameters that are already predefined and precompiled there regarding the potential and the atom-atom interaction. So now let's go to the executables. So what is MCTDHX? What does it do? MCTDHX is a computer software to solve the time-dependent Schrödinger equation for many particles, and it does so via the MCTDHB equations of motion. And if you don't know what is that, then you should immediately go to the website and look at the supporting documents there and all the citations and fresh up a little your knowledge. But this is the way to, it's an elegant way to tackle quantum mechanical problems of many particles. Now, the program consists of, let's say, three pillars. The first of which is the main program, so the main routine, and this is the executable of that. The program has an input, so you specify some parameters, and it gives you an output after it has successfully run. And this, for instance, would be natural orbitals and occupations of these natural orbitals. Once this program is compiled, then you go to the next step, which is the analysis, and this is the executable of the analysis. So once this is completed, on top of that you run that and you get extra information, like for instance correlation functions, density matrices of higher order, and many other funky but really interesting things. And the last, there are some computer scripts that you can find inside here that can generate plots, that you can generate videos, or based on the data that you have that you have obtained with the program, and also automatization processes that I will be showing you later. So this is mainly the structure of the program. The commands, you can find a nice list here inside the documentation folder. Let's go down, manual.pdf. This is, you can also find on the webpage, but it's in your local installation directory. And then you will find a list of all the licenses used. Some of them are really useful. I do really recommend, like for instance INPCP, which means input copy. So you open up a directory and you type, this guy automatically copies the input file for the main program and then the input file for the analysis program. As I told you, there are two different processes, and the BinCP, which copies, when you execute from a terminal, BinCP copies the executables and it copies the library as well. So as I said again, troubleshooting, if you have a problem, you think your compilation did not work successfully, then you can type xmake at any time from any directory. That's an alias. It will recompile the whole program again. You don't have to. It is already compiled with the predefined potentials, which is a great variety. But if you want to show off to your mom, to your friends, to your colleagues, then you can xmake. So this is pretty much what I wanted to tell you. Bonus for the end would be just some additional software that most likely it's already in your computer, but you should make sure it is there, and so that you don't have problems in the future. So Python, probably it's there. GNU-plot is an all-time classic. It's something that it's really useful for you and for us to plot the data that we have obtained. And Mercurial, you have it, and the MPlayer, also for MPlayer encoder, to make videos from what we plot there. So go ahead and type that in your terminal, make sure everything is there, and I'll see you in the next tutorial. We will set our very first simulations for quantum particles in a trap. And until then, enjoy MCTDHX.